Hello, thank you so much for coming to our short talk for ACM Fact for our paper Multi-Stage Screening, Enforcing Fairness and Maximizing Efficiency in a Pre-Existing Pipeline. So this is joined with my amazing advisor, Avrim Blum, and my fantastic collaborator, Vakilian, and we are all based at TTIC in Chicago. So let's get into it. So our project started with thinking about a fairness harm caused by scarcity. So in this scenario, assume that there's a small estimated gap in some quantity between groups. So if we're doing binary classification, at the very end of some classifier, you have a pool from group A that is 60% positives, like true positives, and you have a pool from group B that is 55% positives. And so the company is trying to has some sensitive resource or costly quantity that is trying to minimize using this decision-making tool by assigning the people who get the decision to the group that looks more positive. And in this case, maybe it is more positive. And because the company really cares about minimizing its cost, you should think it has a high cost here. Even if there's a small gap between the groups, the company may say, all right, if I don't promote anyone from group B, or I don't make the high stakes decision for the positive decision from anyone from group B, I can minimize my cost by just going with group A. So I'm going to do that and have this kind of discontinuity. And that's clearly a fairness harm of sorts, because we're thinking that this difference is very small, and then the positives from group A, they don't get a shot at all. And so one kind of sort of natural response to that, and sort of maybe a good primitive in practice, is to say, all right, let's require group fairness constraints over the entire pipeline as kind of a baseline response to that fairness harm. And so our research question is, okay, how do we do that and exhibit a high utility, in this case, pipeline screening process from the perspective of the firm? So that's kind of the fairness harm. Sorry, that's the fairness, that's kind of the motivation thinking responding to this type of fairness harm. And a scenario which we kind of zoom in to study, which we think this type of harm occurs and is problematic, is thinking about screening processes or hiring processes in our paper. So the idea here is you have a bunch of tests that are cheap, that are sort of early round interviews, maybe they're automated coding screens or something that the company can deploy cheaply. And at each step, you're filtering out some positives and you promote people who pass the test and according to some policy. And the goal is to get to the very end where from the company's perspective, it's mostly positive examples that are then promoted to this final costly step. And so the final step is costly. And what the algorithm can do is we assume the tests are fixed, and then to achieve our fairness goals and have a useful classifier, we change how the tests are used. We change how people get promoted through the pipeline. And so that's our model. There are related models that I'll discuss more in the longer version of the talk from prior work. And so some issues are some just baseline issues. This is not convex in pi, which is the promotion policy. And if you just care about maximizing precision at the very end, we have a very simple closed form solution about what you should do. And then if you care about precision and recall at the very end, things get more complicated. We have some negative results and we exhibit some general algorithms. And I will discuss this all in greater detail in the longer version of the talk. And I'm excited to talk to you guys about this problem and related problems. So thank you very much for listening.